Hello, so this is going to be performance task 5, questions 8 through 10. First, we're going to start with question 8. A gaseous sample of the substance has a pressure of 1.12 atmosphere and a volume of 2.5 liters. If the pressure is increased to 1.5 atmospheres, what is the new volume? So for this question, we are actually given assume constant temperature in moles. So with these given, the most likely gas law is going to be Boyle's law. We know that Boyle's law, the equation is pressure 1 and volume 1 is equal to pressure 2 and volume 2 of a system. So we're given a couple of things. We're given pressure 1, pressure 2, and volume 1. So this means that we need to solve for volume 2 because we are not given volume 2. So we're going to take all of our variables and we're going to plug them into the equation. So P1 V2 divided by P2. When you plug this into the calculator, you're going to get this number, which is the final answer, 1.87 liters. Now going to question 9. A 0.85 mole sample of the gas has a volume of 1.25 liters. If 0.55 moles of gas are added to the sample, calculate the new volume. So for this answer, temperature and pressure are going to be a constant in this problem, which means that the most likely gas law is going to be Avogadro's law. Now, we know Avogadro's law to be volume 1 and number of moles is equal to volume 2 and number of moles of the new system. So we are given, again, we're given a couple of variables, number of moles, volume 1, and number of moles of the new system, which we know to be equal to number of moles of the original system plus the given added 0.55 moles. So from here, all we're going to do is we're going to solve for V2 because we're not given V2. So we're going to take volume 1, which is 1.25 liters, and then we're going to take number of moles 2, which we calculated previously, 1.4 moles, and then we're going to take N1, which is 0.85 moles. We're going to plug this into the calculator. We're going to get 1.25 times 1.647. That's going to equal 2.06 liters as a final answer. Now, moving on to question 10. A gaseous sample of 1.65 moles of gas has a temperature of 305 Kelvin and a volume of 2.75 liters. What is the pressure of the sample? So for this, we are given temperature, moles, and volume. We are not given pressure. So the most likely law for this is going to be the ideal gas law, which is pressure and volume equals number of moles times the ideal gas constant times absolute temperature. So we are given lots of variables for this. The only thing we aren't given is pressure. So we're given number of moles, volume of the system. We know the ideal gas constant from our textbook. We're given absolute temperature of the volume, which is 305 Kelvin. So ultimately, we're going to solve for pressure. We have the following equation set up. Pressure equals ideal gas constant times temperature times number of moles divided by volume. So with this equation, we're going to take 1.65 moles, multiply it by our ideal gas constant, multiply that by our absolute temperature, divide this whole thing by our total, our volume of 2.75 liters. That's going to, the top part will give us 41.3. This carries, so 41.3 divided by 2.75 liters equals 15.0, but because we know we're solving for pressure, the standard unit of pressure is ATM, so it's going to be 15 atmospheric pressure.